Hello, everybody who has looked at my Prezi and done and looked over the idea about volume of revolution washer method. This is some extra help and examples in case you didn't understand my step-by-step solution. So I'm going to go over the first example here with you. So let's just start out. So the first question is, find the volume of the region enclosed by y equals square root x plus y equals x to the squared is rotated about the x-axis. So here, as you can see on this graph that I drew, we are trying to find the area of this enclosed region right here. So if you equal both of the equations to each other, you will find the points where they intersect. And we notice that if you plug in 1 for both of these equations, then you will find where they intersect. So the first place, which I just stated, was identifying the region. We found the region where it lies between, which is from x equals 0 to x equals 1. Now, our next step is to actually select the axis that we are going to be rotating this shape on. So it's stated in the question that we are rotating about the x-axis. So that kind of gives us our answer. So we are going to integrate with respect to the x. So now, since we have figured this out, we can actually determine our limits of this integration, which is seen on step 3, which is from 0 to 1. So the next step, which is a very important step, is you have to find which function is on the top, which is an outer function, which is an inner function, because the equation states that it is outer minus inner. So we can see that the outer function is y equals root x because it's actually on top of the other function, y equals x squared, which is the lower function. So f of x will be considered y equals square root of x, and g of x will be considered y equals x squared. Now, since we have set up these inner functions, these inner and outer functions, we can now solve for the volume. So this is the first step we're going to do actually before we integrate. So you can see that the equation here is v washer equals pi of f of x squared minus g of x squared dx. So that is actually the equation for finding the volume. So here in this next step, we just plug in these points. So pi equals root x squared minus x squared to the squared dx. So we can simplify this to pi equals x minus x to the fourth, or pi of x minus x to the fourth dx. Now this is the equation that we will actually use to integrate. So now on step 6, we can actually integrate to find the total volume. So we set it up from the points of 0 to 1, pi x minus x4 dx, and this is where we can actually evaluate. So as we see on step 7, the first step is to state the equation, and the second step is to actually do the integral. So the integral of x is x squared over 2, and the integral of x to the fourth is x to the fifth over 5. So now we can actually plug in our 2 points of integration. So first, we plug in the top number minus the bottom number. So we plug in 1, and we get pi of 1/2 minus 1/5, which can be resulted to 5/10 minus 2/10. So that is 3/10, and then you just add the pi, which we get 3/10. And the reason we don't do any subtraction is because the lower point of integration is 0. So that is the answer for our first problem. I hope you enjoyed, and I hope you learned a lot, and roll tide roll, baby. Okay, so for our second problem that involves the volume of revolution washer method, I chose a little bit more difficult question so we can try to challenge our complexity here. So the second question, it's the same idea. It's find the volume of the region enclosed by y equals x squared plus 1 and y equals 2x plus 1, but it's rotated about the y-axis. So we are actually rotating from a different angle around the y-axis rather than the x-axis, which is going vertical strips instead of horizontal strips. So the first thing we do, once again, we graphed it out. So I graphed out both equations, and I figured out that at point 2 is where these points actually intersect, because if you plug in 2 to x squared plus 1 or 2 to 2x plus 1, you get 5. So we know that the points of integration on the y-axis are from points 1 to 5. They lie between y equals 1 and y equals 5. Now, so once again, we are supposed to select the axis, and as it stated in the question, we are rotating about the y-axis. So when we rotate with respect to the y-axis, or with respect to x for the y-axis, we actually have to flip the equations with respect to x. So as you can see under step 2, we switch y equals x squared plus 1 to root y minus 1 equals x. And the same goes for y equals 2x plus 1. We have to switch it to y minus 1 over 2 equals x, because we have to do this with respect to x. So now we are once again able to set up the integral, because we have both of the equations and the points of integration. So as you can see on step 3 is the integral from 1 to 5 of the outer function minus the inner function. Now, what's different about the y-axis is actually if you turn your paper horizontally, if you're looking at it from the y-axis, you can see that y equals x squared plus 1 is actually the upper function, while x squared plus 1 is the lower function. So, as we stated in number 4, the square root of y minus 1 squared will be the right word, or just square root of y minus 1 will be the rightward or upper or outer function, and y minus 1 over 2 will be the inner function. So for this equation, I don't think that we should simplify for the volume, as we should go directly into the integration, as I feel like it's sort of repetitive. So here on step 5, we can just state our entire question by just plugging in the values. So we plugged in the outer function right here and the inner function to the right, which is seen on the first step in step 5. So here we have the integral of 1 to 5 pi of root y minus 1 squared minus y minus 1 over 2 squared dy. So first, we have to actually simplify this equation, because we want to get rid of the squares. So we get the integral of 1 to 5 pi of y minus 1 as the square root cancels out, and y minus 1 squared over 4 as we have to square both the top and the bottom. Now, this is where the real integration point actually occurs. So the first step of integration right there is we have to take the first step, or the outer function y minus 1, and do the integral, which is 1 over 2 y minus 1 squared. That's just a regular integral steps. And then for the other one, we also have to do this same step, as it is 1 over 12 to y minus 1 cubed. And that's because we have to raise the root and do 1 over the opposite on the bottom. So this is actually where we get into our integration. And now we are actually evaluating the integrals to find the volume, since we have our equation. So this is where we plug in 5, and this is where we plug in 5 to this integral, and then subtract it to 1, as those are our points of integration. So after filling everything out, we get pi times 1 over 2 5 minus 1 squared minus 1/12 times 5 minus 1 cubed. And this is just as we're plugging in points 5. And then we subtract this as we're plugging in points 1 half 1 minus 1 squared minus 1/12 1 minus 1 cubed. And that, since it's 1 minus 1, it just equals 0, so we can honestly cross it off. As we can see in the step under, it's just 0. But the 5s actually create a number. So if you simplify, you get, for the first one, 16 over 12, as 5 minus 1 is 4, that's squared, that is 16, and you put it over the 2. And then for the next one, it is 5 minus 1 cubed, which is 4 cubed, which is actually 64, and you put that over 12. And don't forget the pi. The pi is very important, since it is volume of revolution. After I got 16 over 2 minus 64 over 12, I was able to subtract these two numbers by making a common denominator. So I actually multiplied 16 over 12 by 6, which gave me 96 over 12. And that I subtracted by 64 over 12, which gave me 32 over 12, which is divisible by 4 to simplify, which gave me 8 over 3. Then I just added the pi once again, and that gave me the total volume of revolution. Roll Tide, roll as always.